G'day, Michael here. This video is a follow-on from the previous couple of videos in this series where I did a sample measure up of a pretend wardrobe environment. This I made basically a 1/4 scale, so these numbers I'm going to multiply by 4 just like I did in the 2D example, and these measurements here I'll keep as literal. Okay, so it's a bit of a kludge, but yeah, we'll roll with it. Alright, now I have a 2D CAD package called CAD, which you saw in the previous video, and I also have a 3D CAD program called VariCAD. Where am I now? Okay, now with CAD, I'll just load that. You saw how I used the set out lines to transfer dimensions from one view to another via these set out lines. I'll just flick them on and off so you see what I'm talking about. These lines were set up for transferring those details. So set outs here and here, and there was also a face set out. So I use that method to transfer dimensions up from the front elevation and to the side from the front elevation, and to share from the plan view across to this end elevation or section. I have this 45-degree angle line. Now the inherent danger with that is I might go to the wrong side of a line. Say this bulkhead here, which you can see in the cyan colour, I may have put in the wrong spot. So I'll just flick that set out off so you can see what I'm talking about. There you go, you've got that. That could have been put on the wrong side of a line. There could have been perhaps confusion as to whether I stop. What is that? What is that? Okay. Could be confusion as to whether I have the back underneath the top or going through, and if I'm not consistent with my thinking, with my drawing across the three views, I can leave myself in quite a pickle, having three different sizes for a single component, two different widths and or two different heights. So there's a potential for quite a bit of lost information. Now with a 3D CAD, you don't work with lines, you work with objects, three-dimensional objects. And I played with a program called VariCAD. I've got it installed on this machine. Graphics. No, I haven't. Okay, well I will install VariCAD right now. Give me a second. There we go. Get install VariCAD. Password. Open the repository. Yep, there's a lot of that, so I'll let it do its thing. Anyhow, while that's installing, I might fire up VariCAD. Where are we? Where are we? VariCAD, not field. There we go, VariCAD. Okay. So we're installing VariCAD just so I can poke it with a stick and demonstrate its concept. Now with VariCAD, unlike other CAD programs, you work from only local measurements. Everything's relative to the objects you're drawing. In other systems, you're relative to the X, Y, Z zeros. On VariCAD, that's not essential. You can work with a point off anything, any relative point. But I guess in the real world, you only have a relative to something, like you're measuring from the corner of the wall, or you're measuring from Greenwich if you're measuring time, or longitude and latitude, that kind of thing, from the equator. It's all relative to something, and the whole planet's moving. So there's no such thing as a 0 point anyway. It just can exist numerically. But in VariCAD, we don't really work with X0, Y0, Z0. We work relative to a part we're designing. Okay, now let's get those sketches back up. Okay, so I'm going to do some simplifications here. I'm going to call this all a right angle. No funny angles, no radii or anything like that. And I'm just simply going to let the 32mm infill, the bulkhead and the kick take up any discrepancies that are represented by these wonky corners, etc. that we saw in the original. Okay, so first thing I'm going to do is just create the back wall. So I'll do that right now. The height's 2400. I might just bring that sketch up. CH, ceiling height 2400. The width is 570 times 4, because I'm scaling up those numbers from that other one, that one. I'm scaling up these numbers by 4. And the depth, I'll make the wall as 100 just to give it a thickness. It's an arbitrary thickness, it doesn't matter. That's our wall colour. Well, that's what I use for a wall colour. Now, I don't know why this happens, but the initial one firing up VariCAD the first time, for some reason it lays the width, depth and height in that orientation. I'm going to click on that, go -90. I really don't understand why this is so. Maybe someone can let me know. Alright, so I'm going to right click. Now there's a couple of things with this view. This is basically square on. So if I press this view, I'll be seeing the front view. That's a right hand view, left hand view, rear view, top view, bottom view. Now I'll put it back to the front. Back to the front, that's interesting. Okay, now the way VariCAD deals with perspective while you're creating and manipulating, it does it more like an isometric drawing. So I'll just massage that around so I'm seeing what I'm trying to show you. Okay, now with isometric, can't quite emulate that perfectly here. Okay, you can see you've got one axis going off in this angle, about 30 degrees, that angle 30 degrees. But each vertical line is the same length. Each of those ones going off from that axis are the same length. All the lines going off in this axis are the same length. Which plays tricks on your brain, because your brain wants to see, when I do this to it, it wants to see that perspective as if the rear was narrower than the front. That's not what's happening here. All three of those, the visible lines here, are the same length if they're in the same axis on a rectangular prism. Okay, so it may look a bit weird, but it's simply everything is parallel and equal in length. Whereas if I wanted to view in a perspective, VariCAD calls it precise displaying. We can change our perspective, you know, how much exaggeration there is on that perspective distortion. Okay, we might change the light position. We can change where the light is coming from, and so forth. But it is not really a photographic setup. Now just check I'm looking at it from the front. There we have it. Now I'm going to draw the other wall. Now it's switched back to that sort of isometric style. Now what I might do is just rotate that at an angle so you can see what I'm doing a little bit there. We need to be able to see 3 dimensions so we are reliably picking on a given point. Obviously if we're looking at it from the front, we can't tell whether we're using the front corner or the back corner from this angle. That's why I do, well, you have to put a bit of an angle to it. Alright, so go back to our sketches. The depth front to back is 177 millimeters on my original drawing, which we're going to multiply by 4. So the width now is going to be 100, and the depth is 177 times 4. But we've also got to have it including the 100 millimeters from this other wall, because I'm going to lap it past here and put it on the end. It'll make sense in a second. Now VariCAD places any new design with the same XYZ coordinates as a reference to the last object we create. So I'm going to use 2 points as my manipulation tool, measuring tool I should say, in that direction. Bang, so there it is. Now 177, I'll just use the calculator just to demonstrate that. The calculation we had was 177 times 4, 708. So in a perfect world we should have, measuring from this front corner, actually I'll get that calculator back up, always on top. Okay, so I'll get back to VariCAD. From here to there is 708. So that is why I added the 100 millimeters, so as to give that last bit of depth there that we need. Alright, so I've got that wall drawn in. Okay, close the calculator. Now I'm going to draw this other wall, just an arbitrary width long enough to do the job. Here we go. I'm going to make it, I don't know, 1000. 0. Again, I'm going to use manipulation, defining a vector. and I'm going to use 2 points to define that vector. Far corner, that edge there. There we go. Now that was 1,000, but of course we lost the 100. So from here to here will be 900. Okay. Now I'm going to put a bit of wall on the end there, just again an arbitrary bit. I'll make it, I don't know, 500 wide. Oops. 500 wide. 100 deep. And again, it's an oddball spot. 2 points. Now all these programs have got shortcut keys, so you don't necessarily have to go searching around for icons, etc. For argument's sake, if you look in the menus, you can see there's shortcut keys for just about any process. You can see the highlighted things are underlined. So Alt O P, P C would give you a thread or a screw. So you can, if you look for the shortcut keys, all the programs work this way. It's not restricted to VariCAD. If there's things you find you're using a lot, get to know the shortcut key, and you save yourself a lot of clicking around and searching. Okay, so there's our wall, but it's basically 4 objects. So we can make it one single object by using this and calling it add solid. So adding this solid to that solid. Now it's one object. If you pay attention to that detail, you can see the joint line in this area here has disappeared until I put my mouse over it. Whereas you can see those other 2 joint lines still exist. So if I click on this, which is now one object, and add that to it, that other line is just gone. So do that again. Now the whole thing is one object. Okay, so we now have the wall created. What have we got reference to? Well, we can put the kick in place, and we can put the bulkhead in place, because we can refer to this wall to give us those placements. Okay, now what are our details? We have a 150mm bulkhead, a 100mm kick, and basically goes from one wall to the other. Okay. I use this colour for faces. Generally, VariCAD's got, as you saw, I don't know, what's that, about 32 colours? Didn't pay attention. 32 colours. I use them to denote which kinds of materials or finishes they might be. I don't use it to be photorealistic. Okay, so the height is now going to be 100 for the kick. Yeah, 100 for the kick, right there. The width is going to be measured from our wall here. I'm going to pick this point and that plane. Now you can see here how the CAD program has to work continuously in floats. Unlike 2D CAD, which can simplify and round off, because it can afford to do that, 3D CAD doesn't have that luxury. Because 3D CAD, as soon as you're cutting a circular shape or whatever, any approximation may in fact produce an error you shouldn't have. But I can mainly override this and make it 2280. There's a limit to how much they can clean up these numbers, because they must stick to floats. Okay, and the length, front to back, 16mm is the thickness of the board. Okay, now it's going to put it somewhere crazy, centered on the last object. Okay, so what I'm going to do now, move it using 2 points. I can just press enter. I don't need to click on that. I just press enter. I'm going to put, zoom in, make sure I'm doing the right thing. This front edge to there. Okay, so now it's oriented to that location on the corner. Now, the cabinet was, the face of the cabinet is set, you can look at that, is set 20mm back here, and there's a further 40mm to the kick. So the overall of that, as you can see on this drawing, is 60mm. So I'll draw the 3D to the same convention. So I'll put that back 60mm. Right, that's that done. Right click, places it there. Next one. I've changed this height to 150 because our bulkhead is 150. Okay. Now, of course, it creates it in the same location as the kick. Now, for this drawing, I'm leaving the kick in the same place, same depth front to back as I did the kick. So the bulkhead and kick are flush with each other. I did that in my previous drawing. Now I will be doing this drawing by hand as well, so you can see that. Basically, the bulkhead and kick are in line, as you can see there. So I'm going to move that up in that axis, measuring point to plane, end of that, to that surface. Okay, we now have our kick and our bulkhead. Now let's do the infills. The infills are 30mm wide, and they are the height of that space between the kick and the bulkhead. So let's do that. The height. I'm going to demonstrate the difference between, say, 3D points. If I was to use 3D points, there's increased likelihood of an error. Let's say I use this front edge and measure down to this edge. I should be measuring to the front, but if those two objects are not flush, let's say I accidentally pick the back edge, or it may be not possible for me to pick the same plane, we end up with this funny number. Okay, if I use point to plane, it doesn't matter so much where I'm measuring from and to, so long as, so I can actually have my mouse just on that plane over here somewhere, and it measures the square height. So it helps resolve, our dimensions based on a surface to a point. Very handy tool. I live on that. I'll probably do 80 or 90% of my measuring as point to plane. Okay, so that's its height. The width needs to be 30, and the length is still 16. Length being front to back. Now that's going to be put in some crazy place. It'll be where the bulkhead is. There we are, up there. Now to put it at hand, I'll just pick on a place nearby, and there it is. Now you notice it is actually centered on that point, so I'm going to bring it out half of 30, which is 15, because the infill's 30mm wide. I could measure that, but I happen to know it, so let's do that. Then the next thing I'm going to do, and here's where you see point to plane, I'm going to use this direction. Now I'm going to measure point to plane. There's a couple of different ways we can do this, but I'm going to go this front corner to that front surface. Now we're going in the opposite direction to that arrow, so I'll make it a negative number. Now that will be, move that around the road, that will be now flush, that surface will be flush with this surface. Now we want it to go back 20. I've done it in 2 stages. I could have subtracted 20 from 52, etc. But I like to see it in stages just to make sure. Okay, now I'm going to make a copy of it in this axis, and I'm going to measure again point to plane, because I can't actually, there's no point the right distance from this point over to there. So here's again where point to plane works very well. All I have to do is pick that point and that plane, and it's giving me the right number. I'll want a copy, one copy. Big about it all. We've got now both infills drawn in. Okay, now we're starting to get a handle on the shape. Now I'm going to draw the cabinet. Well, there are 2 cabinets. Let's just have a look at those sketches. We have 2 pairs of doors which indicate 2 cabinets, and I'll draw those cabinets using 2 different methods, and both methods naturally have their advantage. Okay, so the first one I'll do just as a big block. Let's do that. Now, the height, well, it's the same height as the infills were, so that's all okay. The width, I can use 3D points here, but I have to make sure he's the same point. That's that. Right, so it's going to be 2 cabinets, so I'll divide that number by 2, and of course you could have done that in your head, that's fine. Right, front to back, I'll go point to plane, this point to that plane, there's our depth, and what I use as my carcass colour is just this, I'm going to call it white. Okay, so we've got this box here in space in a funny place, centered on the infill. Let's move it. 2 points, I'll press enter key. I'm going to put this point here in line with that point there. As you can see, the two corners meet like that. So there's that box. Now, that doesn't look like much of a box. So what I'll do is I'll start managing the objects we have here. As you may have seen in the 2D CAD package, we had layers. Well, we don't kind of have layers here, but we do have groups possible. And it's 3D groups, so 3GR is the command in VariCAD. Other programs will have a different method. Create new group, and I'm going to say on the walls. Group, create new group, faces. These are fairly similar to the groups I had in the other drawing in the 2D. Tick and bulkhead. Carcass. I think that should do. I might think of something else later. See how we go. Now I'm going to add to this, right click, add remove solids. And this will be easy because it's one object. Then we've got kick and bulkhead, add remove solids, that one, and that one. Faces, add solids. The only thing we have as faces is this infill. And that infill. Done. Carcass, add a solid. Okay. So what I can do, I can just on the spot go, let's blank that thing off so we can see through it. Or if I want to be able to, like if I did that, it would simply disappear. Let's unblank it. What we can do is do 3GR again. So do group management. Now the walls, what I'll do is wireframe the walls. That looks good to me. So now I can look at, straight through, I can look at the carcass. Now, using a block like this is all well and good, but if you have to have like a normal carcass or a normal box where you can see inside it, we have to make it hollow. Now this box done like this, we can use a tool called shell, and we simply, I don't know, make sure we're picking the right faces. Now that doesn't look like much, everything's just turned brown. And right click to say yes, I'm ready to go further. 16mm is the right thickness. If I needed some other number, I'll type that in there. Now you have two options here. The shell is an additional layer, so that would be added onto that, or the selected surfaces are the outer surface of the shell. So in other words, it'll go inwards from that. And we can remove an original part. I'm going to go OK. So it doesn't look like much has happened, but when we swing it around, you see the magic. There we go. We have a box. So that was a pretty snappy way of creating a box, carcass type thing. Now the other way of creating a carcass, which is the other one I mentioned, the height of that will be 16mm. It's still the same width, it's still the same depth. So basically it's the same footprint, but we're only making, say, the thickness of the board. Let's do that. It's going to be exactly the wrong spot. And we can simply move it. We know that's 1110, so we can type that number in, or we can measure off the drawing. I'll just type in 1110. Oops. 0, 1. There we go. Right. Now that we need to have a copy of. There's one there. We'll do a copy there. And it'll be 2150 would be the overall dimension, but of course we need to be 16mm less than that. So 2150 less 16, make one copy. Boom. There we go. So I've got the top and the bottom. Right. Now, we'll create the back. The width will be the same as that. The length front to back will be 16, and the height will be, we can measure between those 2 points, or we can type in 2150, because I happen to know it, that's 32, or 2 times 16. Okay, it's going to put it exactly where we don't need it. So I'll just move it, press enter. Now let's point there. There. Okay, now we've got to do the two blades or ends of the cabinet. A new measurement that we have not used before, distance point to plane.
looks about right. Width is now going to be 16, and the height is the same as the back. Let's do that. Again, it's in a crazy place, so put it where we want it. 2 points. Okay. Now we can repeat it using a measurement. We know it's 1110. It'll be 1110 less 16, or we can measure. We go point to plane. Let's say that point, that edge, make one repeat, go. It's that. Now I'm going to do two designs here quickly to show you how easily it's done. My first design is going to be just the 2 doors like we have in the previous drawing, but then I'll make a substantial modification by shortening the doors on the right hand unit and putting, say, 3 drawer fronts in it, just so you can see how quickly we can modify, manipulate, fix errors, etc. in a drawing with a CAD program versus the real life, or if you have a handmade drawing that's more complicated. So here we go. The doors have to be face colour. Let's do that. The height was 2150, but again we could measure it off the drawing if we wanted to. I know that it's 2150. The width gets more interesting. It has to be, I use between 3D points. I know it's 2220 because that's what the carcasses were, but we should get the same number just to demonstrate how that can be done. Now, if we have 4 doors, then we'll have 5 spaces. So what we have to do is take away one of the spaces so we can divide up the distance by 4 equally. So 4 spaces and 4 doors in our number. Once we've taken away 2220, we'll take 3 away from the 2220, which will give us another number. But here's where you've got to pay attention. Mathematical order is multiplication and division before addition and subtraction, or if you're using indices like squaring, square root, that kind of function, that happens before multiplication. So here we have 2220 less 3. Let's just do that here in the calculator. 2220 less 3 divided by 4. Now what it wants to do is 3 divided by 4, and then take that away from 2220, and we get some silly number that is of no use to us. Okay. So that's not going to be happy. We have to make sure that this calculation happens first. Okay, so that subtracts that. Then we can divide the leftover by 4. Okay, now that gives us the door width plus a clearance. So then we have to take away 3 to get our clearance. Okay, hopefully that makes sense. Put the calculator up. Actually, I'll get another calculator here. And it doesn't matter if we use it as a scientific calculator, because in fact this calculator here, where am I? Scientific calculator. Actually, it may. Let me just have a look at paper mode. Haven't thought about that one. Paper mode. So if I did 2220, 0 less 3 divided by 4 less 3. That's what that does. Now it still gives us the same sort of calculation. It does the 3 divided by 4 first, and then takes it away from 2220, then takes away 3. So we end up with a different number again. So you can see by doing what seems to be a logical calculation, you end up with an oddball result. So what we have to do here is open parentheses, 2220 less 3, close parentheses, and it does that calculation, which is 2217 divided by 4 less 3. So the answer should be 551.25. Well, let's go. Now I don't know what it is, I'll zoom out. Oh, I didn't change the depth correctly. I'm just going to let that go and delete it. So there's an error. Okay, let's do that again. That width is 551.25, so let's just see that. And 16 is the depth I should have made it. Here we go. Let's define vector, 2 points. Put this front corner here to that front corner there. So that is immediately next to the infill, but we need a 3mm clearance. So I'll do 3.
Now we're going in the direction of the arrow so it stays positive. Just see that move a little bit. Now I'm going to do that again. 3 plus, we happen to have it on the calculator, where are we? That's no good. That 551.25 is our door, plus 551.25, or alternatively we can measure, so that's the number we just calculated, or we can measure, point to plane. So I'll have the right hand of the door here, measured from the other side of that clearance. So we're actually going left hand of the clearance to the left hand of the clearance. So 554.25, which is of course, where are we? What is that? Which is of course 551.25 plus 3. So we end up with the same number. So either way, I don't care how you arrive at the number, but you need to have the number correct. I'm going to make copies. 2, 3. Okay. As soon as I go right click, they will be made. So in a sense, I've actually finished the design as is, ready to go, equivalent to the level at which I drew the 2D. Okay, so basically I've got exactly the same componentry here, but let's just add in the kick frame while we're at it, just to make one exercise. Now the cabinets were 2220 in width, so I'll just the height 100, width 2220, length 16, change it to the white, which is carcass structure. Okay, God knows where that is. So what I'll do is I'll in fact come along the centre of the kick. There, if I zoom in all the way, you can see I'm half over the face of the kick. So I'll just move that out, I'll just turn that so you can see the arrow better. The scale's a bit wonky to use. Okay, so I'm going to come out 8mm, just to be clear of the other piece. Okay, and I'm going to, I don't know, I'll have a space of, I'll change angle so you can see what I'm talking about. Let's do that. I'm going to bring that out 550 plus 16, so we can do 566, or we can do 550 plus 16, same answer. Just how you arrive at it, it's up to you. Make a copy, 1, done. Okay, now I'm going to put a, what's called a bearer between the two. Its height is going to be that, its width is now going to be 16, its length is going to be 550. Now I could measure between those 2 points, I happen to remember the number, so it doesn't matter either way. Okay, now I'm going to find vector, 2 points. Okay, now we know that dimension is 2220 because that's what I typed in, but if you don't know how that's achieved, let's do the measurement. What I'm going to do is copy. I want 5 copies. Now we could again type in 2220 less 16. Put brackets around that. Divided by 5. Okay, and make 5 copies. If you struggle with the mathematics, I'll show you the other method. As you can see, bang, we got that there. They're all there. I'll zoom out. So that was that. I'll go undo that. Now, again, create that. Repeat. The way it works. Point to plane again, or even 3D points we can use here. So we need the inside face of that. Now this is the important bit, that's why we had to remove the 16. That inside face to the far edge divided by 5. So I don't really care how you arrive at the number. That's how it's done. Alright, so we have that. So how the whole point of a drawing is so we can know all the parts. With this method I can go here, okay, this is 2150 by 551.25. I mean, really you probably round that down to 551 depending on your processes.
let's just add those to the face. Oops, 3GR. Add some solids. Okay, so I might blank those solids so we can see the carcasses. Right, now because this was created as one block, if I go to see how big that block is, or edit it, anyway, we're 2150 by 1110 by 672. But that is the overall of the cabinet. It doesn't give me details of the components. Let's go to that, do the same thing again. Because this one was made out of components, each individual component is has got its own dimensions. So I can extract that information from the drawing. So you can see that that would in fact be a better way of getting individual components, whereas this is the total box. Each has its merit. This is obviously a quicker way of doing things. That's not a too bad a way of doing things. Yeah, both have their merit. I'm not going to say one's the best because they both are the best in their own right. Okay, so let's put I'm going to put a fixed shelf at say 700mm up. Now the height of that shelf, I'm going to make 25 because this span is around about well, it's 1100 odd millimeters across, less the end panels. The width, point to plane, don't know the number. I could calculate 11. I just go point to plane. Here we go. Okay, the depth. Point to plane again. Okay, it's going to be God knows where. So I'm going to put it define vector, 2 points. Just put the under edge to here. If I lift that up, 700mm, that means the space between these two parts will be 700. Okay. That gives us a fixed shelf there. Alright, so if I unblank those doors, now this door is going to be in the way. If I'm modifying that door, I need to be able to see the shelf to get the measurement. So I'm going to blank that one door just to get out of my road. Okay. Now I want to change this door's height. The hammer's all about. Modify the part. Right click. 2150 is our existing dimension. I've got to change that to, again, a measure point to plane. Again, you can see how point to plane is then advantageous. There to there. Now, that shelf is 25mm thick. The gap between the door and what will be the drawer front below it is 3mm. So 25 take away 3 is 22. So it's 11mm. So it has to go 1409 plus 11. Of course, it puts it in the wrong place. So right click there. Have to go the opposite direction. Done. So now we've got that door. Now obviously I could do the same process for this other door. Okay. But I also could repeat this. So what I'll do is in fact repeat that door to make this door. It doesn't matter which method. That's what I'm going to do though. Okay. Repeat that in the axis. We can look up our number that we had in the calculator, 554.25, or we can measure the point plane. So I've got a door plus a clearance. I'm happy to just type in 554.25 and make one copy. Done. It doesn't matter. Whatever method you choose, that's fine. Alright, now we'll make 3 drawer fronts. The height, I'm going to just use point to plane divided by 3 less 3. Width is going to be 3D points. Okay, length is going to be 16 front to back. The colour is going to be the face colour. Okay, crazy place again. Okay, of course we've got to come out that 8mm again, so -8. Repeat it. $730 divided by 3. 2 copies. In a perfect world, that should be equally spaced. But there will be some skewy offsets because the cabinet is not exactly concentric on the doors. Because there's a 3mm difference on the right hand side and a 1.5 on the left hand side. So I'll zoom in on that so you can really see what I'm talking about. Front view. As you can see, that is not flush. So while these things are still red and highlighted, I can do a manipulation in one axis, and it's going to be point to plane again. Zoom in so I can get a handle on it. So from this point, do that plane, whatever that distance is, but the arrow was going to the right, so we have to go the opposite direction. Boom. So that should be, in a perfect world, where am I? Look that up. Okay, here we go. Perfect. So naturally, our objective now is to produce a dimension set of drawings, and basically I'm not going to show the process of putting dimensions on everything. We'll just simply pull the views out from the 3D to the 2. And that's the tool here. This is the front elevation. Okay, we've got options of carrying through information from the 3D to the 2D. I'm showing here, do not draw hidden lines, so it will give you the view from the outside without anything hidden. Okay, let's do that. Takes me to the 2D thing, 2D view. I'll just go insert. I'll do the same process again, go back to 3D. Now I'm going to show hidden lines the same as the visible lines. So it'd be like everything's made out of glass, I can see straight through it. I could choose using a hidden detail attribute. I'll just leave it as this. Translate to another position. I just like using points off the drawing, it's just easier that way. Translate to another position. I'll use the width of the drawer, that's good enough offset. So it'll be the full width of my drawing plus the width of the drawer apart. That's just an arbitrary space just to make it visually okay. Now I'm going to have a look at it from above. Okay. Now the different drawing packages have different methods of producing these different views. Translate to another position. Okay, so we have a plan view, 2 different front elevations. It basically is that. Then you could run around and dimension it rather like I did on the 2D. We can also throw in a bit of a sort of an isometric, not perspective, but isometric style view. Just massage it around. Give some sort of handle on what it looks like as a 3D. Okay, so again we go to 3D to 2. I won't draw hidden lines. Okay, and I'll translate to another position, which will be in that point, perhaps in line with that point, and then translate a bit further. That'll do. Okay, so we've got 3 views laid out here. Again, we dimension that based on what we see, just to get the same kind of view as we had with the dimension drawings here. So it's up to you how you want to do it.
We could even do a reverse plan. Let's go back 3D again. Look at it from underneath using that view, and you can see where the kick frames are. Let's convert that. Do not show hidden. That's fine. Let's do that. Okay. Translate to another position. Okay, so this is drawn straight through from above. So okay, I didn't necessarily have to do that because it's showing that way. In any case, you'd have to label this. I might actually take that view out and do it from above again. Slight error. Do it that way. Okay. Here we do. So we've got a top and a bottom view. You'd have to label that clearly if you want to print it, so people understand. Now, because I keep the 3D model at hand, I tend to just pluck the dimensions directly off the drawing. As you saw, we can just do this too, as if we're going to edit the design, and it gives us the part sizes. Okay, so I think that's it. Yeah, I think that's all I need to do, and that's all I can do. Of course, if you wanted to email a perspective, go view, precise displaying, and you can make perspectives more believable. Now the shading's all oddball, so I better change the lighting. Set light position, change selected property. Then I better, okay, back. I'm also going to go 3GR, which is probably going to drop my perspective now. It did indeed. Make the walls shaded. Back. That would be a fairly natural perspective. Eye line about this level. Okay, so you could do a screen print. The CAD program may have a high resolution bitmap output. I'll just do a screen print just to be simple. Okay, so now you can see my whole desktop there. So you might want to crop out that area, whatever you want to do. So that'll be all there is to it. So I could, I don't know, let's just, I'll call it, I don't know, cabinet, PNG. I'll save it in. Hold on. Alright, so I'll open it in Shotwell. Here. Crop. And you might want to just crop it down to something that's sensible. Done. Alright. So there we have a view for the customer. Now I'll just open it in the regular viewer. There we go, is our little cabinet PNG. So that could be emailed to someone, whatever. So there you have it. You can even do like I'm doing now as a screen recording. You could rotate it around. You could actually send a small video to where everyone needs to see it. Alright, well that's it for this video. Feel free to like, share, subscribe, ask a question, leave a comment, make a suggestion for another video, even make a donation. Every bit of support is a good thing. Yeah, bye for now.